In this video, synthesis and integration of different elaborations on finding metropolitan solutions will be given. Background are the main questions as stated in the beginning of this MOOC. The focus will be on integrated, so-called green-blue solutions based on regenerative systems, and in particular on how to plan and integrate these in the built environments, achieving potential economic profit and, foremost, prosperity for all citizens. Including regenerative systems can be considered both a mitigation strategy as well as an adaptation strategy, depending on their application, of course. But the elaborations shown here will focus foremost on the integration in existing environments, as this will be the most important challenge of the coming decades. Main question then is how to achieve more sustainable and preferably closed cycles in our metropolitan areas and how to integrate them. So in this video we will focus on the third aspect as shown in the AMS approach to develop new solutions, how to integrate technology and in particular sustainable alternative technologies in our living environment. You will find out that they request a reconceptualization and include smart, integrated, multi-layered regenerative systems. But also it addresses both the need to consider the metabolism of cities as well as creating multiple synergies through an ecosystem services approach. It is important to be aware that it still is really hard to achieve so-called full closure of systems to support our living, similar to that of our terrestrial biosphere. A well-known project that showed this is the so-called Biosphere 2 project in Arizona. In this project, initiated by a private investor, billionaire Ed Bass, a separated biosphere was created including different ecosystems representing all climate zones on Earth. The idea was to achieve a self-supporting system and to have 8 researchers live for 2 years inside the project without interference from the outside environment. Mind you, only 8 persons with such a huge footprint and complex of buildings. The project in general is considered as a failure, as the planned 2-year isolated stay of the 8 carefully selected researchers was aborted. One of the reasons were social problems. Regardless the space, the people living in Biosphere 2 had many irritations amongst one another. But also, and that is also evaluated as one of the possible causes of these irritations, there were technical failures and a lack of food. The oxygen level, for instance, dropped from 21% to 14%. As a consequence, to chemical reactions with concrete, amongst others. But also, the natural systems didn't function as planned, which resulted in a much lower growth and resulted also in a lack of nutrients and food for the people living there. Altogether, the project showed the sensitivity of natural systems and indirectly also how magnificent our one and only terrestrial biosphere in fact is. We'd better take care of this one first. At the moment, the Biosphere 2 complex is still used successfully, but only for all kinds of research projects by the Arizona State University. Natural systems are key to life. They are often also referred to as regenerative systems. They are characterized by the ability to incorporate continuous change based upon a concept of resilience. But if we really want to base solutions on natural systems, as I aim for in my field of expertise, it is important to be aware that these regenerative systems need continuous care and maintenance, which makes also the main difference with industrial systems or so-called hard technologies. Within regenerative systems, energy is replaced by incoming solar radiation, while materials are replaced by recycling and reuse. The use of such natural systems for everyday metropolitan challenges, such as shown here the problem of air quality and particle matter, or fine dust, provides solutions that combine the practical with responsive to changed and good-looking solutions, all, of course, if well integrated. Certain plants, like shown here the Clematis hedera, due to special characteristics such as sticky leaves, can catch such micropollutants and thus help improve air quality in metropolitan areas. Of course, the design and integration of such systems requests much more. For instance, the catchment of the polluted effluent of rainwater of these plants and its treatment. But once well designed and engineered, it shows the potential of regenerative systems to address such metropolitan challenges. Another nice example of such an approach, but then applied for the cleaning of urban surface water polluted by sewerage, is the following project by the American Joshua Todd in China. In the Baima Canal, over a length of 500 meters, he designed, engineered and realized a regenerative system to clean the water polluted with toilet waste of 12,000 person equivalents, making it almost an open sewerage, as you can see. Joshua Todd created a floating system which contains a series of floating, carefully chosen plant-filled root-based water treatment modules, together with an aerator upstream to include oxygen in the water flow. As the polluted water in the Baima Canal in fact is to be considered a resource of nutrients instead of waste, the plants grow and flourish within no time, creating in the end not only a cleaner canal, but also a nice and attractive green-blue and accessible park in the middle of the urban area.